Have you ever wondered what it would be like to leave Earth behind and watch the moon slowly grow through the window of a spaceship, knowing that you are participating in a moment that humanity has waited for more than 50 years to relive? The Artemis II mission turns this dream into a concrete historical reality. This extraordinary journey represents much more than just a trip into space. It symbolizes the renewal of the spirit of exploration that drove the first lunar voyages and that now returns in full force, fueled by new technologies, new goals, and an expanded vision of humanity's future among the stars. In 2026, the world turns its eyes to the sky with renewed anticipation. Artemis II represents the first time in decades that humans will travel beyond low Earth orbit into deep space toward the moon. This return to deep space does not happen by chance or nostalgia. It is the result of years of meticulous planning, substantial investments in research and development, and a renewed understanding that the fate of humanity is intrinsically linked to our ability to expand our presence beyond the home planet. The decision to return to the moon reflects a fundamental shift in the way we look at space exploration, moving from a geopolitical competition to a coordinated effort aimed at long-term scientific and strategic goals. This journey is not just symbolic or nostalgic. It marks the beginning of a new phase of space exploration, where the human presence outside Earth is once again a strategic priority for the future of our species. Modern space exploration differs fundamentally from the programs of the last century. While the Apollo missions were primarily motivated by political goals and the Cold War space race, the Artemis missions are driven by a vision of sustainability and permanence. The goal is not just to visit the moon briefly, but to establish an ongoing presence that will serve as a platform for even more ambitious missions, including the eventual exploration of Mars and other destinations in the solar system. 4 astronauts will travel aboard the Orion spacecraft, a vehicle specifically designed to withstand the harsh conditions of deep space, far beyond the relatively protected environment of Earth orbit. The selection of these 4 individuals went through a rigorous process that took into account not only their technical skills and prior experience in space, but also their ability to work as a team under extreme conditions. Each crew member brings with them years of specialized training and specific knowledge that will be essential to the success of the mission. Orion was developed with modern life support technologies, advanced navigation, and redundant safety systems, allowing humans to remain safe for long periods away from Earth. Life support systems are designed not only to keep the crew alive, but to ensure that they remain healthy and able to perform their tasks at peak efficiency throughout the duration of the mission. During the mission, the spacecraft will travel a trajectory that will take it thousands of kilometers beyond the protection of the Earth's magnetic field, exposing the crew to an environment rarely experienced by humans. This aspect of the mission is particularly significant because the Earth's magnetic field acts as a protective shield against cosmic radiation and energetic solar particles. Once beyond this natural protection, astronauts will be exposed to much higher levels of radiation than those experienced in low Earth orbit, where the International Space Station operates. This exposure is carefully monitored and calculated to ensure it stays within safe limits, but it will also provide valuable data on how the human body responds to these conditions. This exposure is intentional, as scientists need to understand how the human body reacts to deep space to prepare for even longer journeys in the future, including missions to Mars. Future interplanetary travel will require astronauts to spend months or even years exposed to the deep space environment. Understanding the physiological and psychological effects of this prolonged exposure is critical to developing effective countermeasures, from medications and nutritional supplements to exercise protocols and radiation protection systems. Artemis II will serve as a living laboratory to study these effects in real-world conditions, providing data that simply cannot be replicated in ground-based experiments or in low Earth orbit. Artemis II will act as a major dress rehearsal. Astronauts will not land on the moon, but will perform a full orbit around it before returning home. This incremental approach reflects a carefully calibrated risk management philosophy. By first performing an orbital mission without a landing, engineers and scientists can verify the performance of all critical systems in real-world conditions before adding the added complexity of a lunar landing. Any problems or anomalies discovered during Artemis II can be addressed and corrected before subsequent missions that will include landings on the lunar surface. This route will allow it to test all the critical systems that will be needed when the next missions try to land on lunar soil and stay there longer. The systems that will be tested include not only propulsion and navigation, but also communications over long distances, life support systems in extreme conditions, heat shields that will protect the capsule during re-entry into the Earth's atmosphere. Each successful test increases confidence in the overall architecture of the mission and reduces the risks associated with future lunar landings. The Moon is no longer just a symbol of Apollo's glorious past and becomes a central part of future plans for human expansion throughout the solar system. The change in perspective on the Moon is profound and significant. In the decades following the Apollo program, the Moon was often seen as a destination already conquered, a closed chapter in the history of space exploration. It is now recognized as a vital strategic asset and an essential platform for the next phase of human expansion into space. This change in vision has been driven by new scientific discoveries, the development of more advanced and efficient technologies, and a growing understanding of the economic and scientific potential that the Moon offers. Recent research indicates that the lunar South Pole may contain water ice preserved in craters that never receive direct sunlight. This resource is vital for future human bases. The discovery of significant deposits of water ice on the Moon represents a revolutionary shift in the possibilities for long-term lunar exploration. These water reserves, protected in permanently shaded craters where temperatures remain incredibly low, are literally frozen treasures that could transform the economic viability of space exploration. Water is not only essential for human survival, but it can also be processed and used in a variety of ways that drastically reduce the need to transport Earth's resources. The presence of water means the possibility of producing oxygen for respiration and hydrogen for fuel, drastically reducing the cost of long-duration space missions. The electrolysis process can separate water into its basic components, oxygen and hydrogen. Oxygen can be used directly for astronauts' breathing, while hydrogen can be used as rocket fuel. This ability to produce resources locally, known as in-situ resource utilization, eliminates the need to transport these materials from Earth, where each additional kilogram of cargo represents significant launch costs. In addition, the water can be used for radiation protection, growing plants in lunar habitats, and various industrial processes. Artemis II is the first practical step in exploring these possibilities. Every piece of data collected during the trip will help shape the next stages of lunar exploration. The scientific instruments aboard Orion will collect information on cosmic radiation, solar particles, magnetic fields, and other phenomena in the space environment. The camera systems will visually document the lunar surface with unprecedented resolution, allowing scientists to identify potential sites for future landings and permanent bases. The crew's experience operating complex systems in deep space will provide valuable feedback for improvements in future projects. All this data will feed into the planning of subsequent missions, making each step safer and more efficient. In addition to the scientific aspect, the mission has enormous emotional and symbolic value for the whole world. It connects generations separated by decades of space history. For those who witnessed the Apollo missions in real time, Artemis II represents a validation that those first steps on the Moon were not an isolated event, but rather the beginning of an ongoing journey. For younger generations who have grown up hearing stories about the golden age of space exploration, this mission offers the opportunity to experience firsthand the thrill and wonder of seeing humans venturing beyond Earth. This generational bridge is important, not only from a cultural standpoint, but also to maintain the public and political support needed to sustain ambitious space programs over the decades. People who watched the Apollo landings will now see a new generation of astronauts repeat the journey to the Moon with much more advanced technologies. The comparison between the technologies of the Apollo missions and those of Artemis II dramatically illustrates the technological progress of the last few decades. Orion's onboard computers are millions of times more powerful than those used in the Apollo capsules. Communication systems allow high-definition video transmission in near real. The construction materials are lighter, stronger, and stronger. Life support systems are more efficient and reliable. This technological evolution not only makes missions safer, but also significantly expands what can be achieved during each mission. International cooperation is also an important highlight of the mission. Several countries collaborate directly or indirectly to make this trip possible. Unlike the Cold War space race, which was characterized by competition and secrecy, the Artemis program is fundamentally collaborative. Space agencies from Europe, Japan, Canada, and other countries contribute technologies, expertise, and resources. This collaborative approach not only distributes costs and risks among multiple nations, but also enriches the program with diverse perspectives and capabilities. International cooperation in space exploration also serves as a model for solving other global challenges, demonstrating that humanity can work together when united by common goals. This collaboration extends the scientific reach of the mission and demonstrates that modern space exploration is a collective effort of humanity. The benefits of this collaboration go beyond the technical and scientific aspects. It promotes mutual understanding between nations, creates opportunities for students and researchers from different countries to work together, and sets precedents for future cooperation on even more ambitious projects. The vision of international teams working harmoniously to achieve goals in deep space offers a powerful narrative of hope and unity in a world often divided by conflict and mistrust. The selected astronauts represent experience, diversity, and technical preparation to face unprecedented challenges in deep space. The composition of the crew reflects a commitment to inclusion and representation. Unlike early space missions, which were composed exclusively of male military pilots, modern crews include men and women from diverse backgrounds, academic backgrounds, and professional backgrounds. This diversity is not merely symbolic, it brings practical benefits. Studies show that diverse teams are more creative, resilient, and effective in solving problems, characteristics that are essential for the success of complex space missions where improvisation and adaptation are often necessary. During the trip, communication with Earth will have a noticeable delay, reinforcing the feeling of real distance from the home planet. This simple detail has great psychological importance and will be carefully studied by scientists. When astronauts are in low Earth orbit, communication is essentially instantaneous, but as they move away from Earth towards the Moon, the delay in communications increases to several seconds. This delay, while small compared to what would be experienced on missions to Mars, where it can reach tens of minutes, still creates a psychological sense of isolation. Astronauts need to get used to making decisions more autonomously, knowing that they cannot rely on immediate responses from mission control in every situation. Orion is also designed to withstand re-entry into the Earth's atmosphere at speeds much greater than those faced by capsules coming from low orbit. Ensuring the safety of this stage is essential for the success of future missions that will return from the Moon with crews and equipment. When a spacecraft returns from the Moon, it enters the Earth's atmosphere at speeds approaching 40,000 kilometers per hour, much faster than the re-entry speeds experienced by spacecraft returning from low Earth orbit. These higher speeds generate extreme heat that can easily destroy the ship if not properly managed. Orion's heat shield is specially designed to withstand these extreme temperatures, using advanced materials that ablate themselves in a controlled manner, taking the heat away as they wear out. The safe return of the astronauts will be celebrated as a contemporary historical milestone. The Moon is no longer just a memory and becomes a strategic destination again. Artemis II demonstrates that returning to the Moon is not the end, but the beginning of something much bigger. The world will follow this journey with renewed anticipation, curiosity, and wonder. This mission rekindles the flame of human curiosity for the universe. It reminds us that there is still much to discover beyond our planet. Artemis II may be remembered in the future as the turning point of modern space exploration. It marks the moment when humanity decided to look again to the sky with renewed ambition. The journey around the Moon will be short in duration, but immense in historical significance. It represents decades of research, planning, testing, and pent-up hope. Artemis II is proof that old dreams can be given new life with modern technology. It paves the way for humans to walk on the lunar soil again soon. And more than that, it paves the way for them to one day walk on other distant worlds, fulfilling the destiny of our species as explorers of the cosmos. If you want to closely follow every detail of this new era of space exploration and understand how these missions can change the future of humanity, be sure to subscribe to the channel and activate the notification bell so you don't miss any updates about Artemis II and upcoming missions to the stars. Leave a like if you believe humanity is ready to become a multiplanetary species, and comment below. Would you embark on such a mission? Which space destination would you most like to see humanity explore? Your opinion is very important to us. Share this video with those who also dream of seeing humanity conquer the cosmos. Together, let's follow this historic journey that marks the rebirth of space exploration. Subscribe now and become part of this community, passionate about the universe.